Hi, chemistry students. This is your Unit 10 lesson on limiting reactants in stoichiometry. Be sure you are taking notes and pause the video as you need to look at each of the examples to try to follow and understand the logic. So, a limiting reactant problem is just like any other stoichiometry problem, except you're going to have to do two problems to figure out which of the reactants will give you less product. The limiting reactant is the reactant that runs out first and gives you the smaller amount. So it's just like any other stoichiometry problem where you're going to need a balanced equation. You're going to look at the given and you're going to convert it to moles, and that's a division by either the molar mass, 22.4 liters, or 6.02 times 10 to the 23rd to give you moles of what you're given. Then you're going to use the mole ratio that you take from the balanced equation. And on top, you will put the coefficient of the thing that you want. And on the bottom, you'll put the coefficient of the thing that you're given to get moles of what you want. And then finally, you'll convert moles of what you want to the units desired by multiplying either by 22.4 liters, or the molar mass in grams, or by 6.02 times 10 to the 23rd. So we're going to do one that is just going moles to moles to sort of show how this works and to possibly take a little less time. So here is a typical limiting reactant problem where we're going to use just moles. It says how many moles of water can be made from 4 moles of oxygen gas and 16 moles of hydrogen gas. Now, so a customer has said, I need a certain number of moles of water, or I need as much water as you can produce. And so you go to your storeroom and you see, oh, I've got 4 moles of oxygen and 16 moles of hydrogen. How much can I actually produce for that particular client? So we're going to figure out what the limiting reactant is, and that's the one that will run out first. And then we're going to figure out the moles of water that you can promise to your client. So again, we're in the whole thing with mole stoichiometry problems. Remember, you're going to have a balanced equation. But since this problem just goes from moles of given to moles of wanted, we just have to do this middle part with the ratio. We're already in moles and they want moles, so we don't have to do the conversions for this particular problem. Actually, 2 problems. So, how many moles of water can be made from 4 moles of oxygen gas and 16 moles of hydrogen gas? So, here's the balanced equation. You always need a balanced equation. This is for the synthesis of water. 2 moles of hydrogen plus 1 mole of oxygen gives you 2 moles of water. Okay? Now, because we have 2 givens, we have to do 2 stoichiometry problems and decide which one will give us fewer moles of water. So you can see I've started with 4 moles of oxygen, and I want to figure out how many moles of water that will give me, and 16 moles of hydrogen, and I want to see how many moles of that of water that will give me. And all I have to do is the mole ratio step. Okay? So we're going to take the mole ratio from the balanced equation. So you can see we're going from moles of oxygen to 8 moles of water by using this ratio that we pulled down. On top we put 2 H2O. That's what we want. That's the coefficient that we put on top. What we put on the bottom is what was given, which was the oxygen. So it's 4 times 2, 8 moles of water. So that makes sense. 1 gives us 2, so 4 gives us 8. For the hydrogen, it's an even easier ratio. It's a 2 to 2. So 16 moles of hydrogen gives us 16 moles of water. Now, how do we figure out how much we have? Well, whatever gives us the least amount is the one that's going to run out first. So the oxygen gives us the least amount, 8 moles of water. So the oxygen is our limiting reactant, and all we can do is make 8 moles of water, and then we have no oxygen left. There will be extra hydrogen left over. So again, you calculate both numbers. Which makes less? The limiting reactant made less. It made 6 moles of water versus the 16 from the hydrogen. So the limiting reactant is oxygen, and the moles of water we can promise our client is 8. Okay, now let's do one that goes like real stoichiometry problems, go start to finish. We're talking grams to grams. This time the client asked for the mass of water in grams. So you have to calculate the mass of water you can make if you go to your storeroom and you see you have 24 grams of hydrogen gas and 160 grams of oxygen gas. How much can you promise your client? Have to have your balanced equation, and we're going to figure out the limiting reactant and the mass of water produced, and we're also this time going to figure out how much excess reactant, whatever's left over. So again, we're going through the whole step. We're going to start with grams, this section right here. We're going to start to grams of the given. We're going to convert to moles of the given. We're going to use our mole ratio to figure moles of the wanted, and then from moles of the wanted, we're going to convert back to grams of water. So we're going through this whole step, but we're doing it twice. So we have two givens, 24 grams of hydrogen and 16 grams of oxygen. And we're going all the way to grams of water. So we have to do each step. We're going to have to convert this to moles, do the mole ratio, and convert back to grams to get our grams of wanted. So let's look at this. This is where you may, at this next slide, want to pause it and really look at it and copy it down. So here are the steps. The first step is we're going to need to convert to moles. 32 grams is the molar mass of oxygen. So I did 160 times 1 divided by 32 because I'm canceling the grams and I'm left with moles of oxygen. If I stopped right here, 160 divided by 32, I would have 5 moles of oxygen. So essentially I have 5 moles of oxygen. Now I've got to get all the way over to grams of water. So I've got to do my mole ratio. So I'm going to pull this down. I want the water. That's my want. That's going to go on top. What I was given was the oxygen, so it's a 2-to-1 ratio. So I'm going to take that 160 divided by 32, 5 moles of oxygen, and multiply by 2. So that means I can produce 10 moles of water, but the client wants it in grams. So I'm going to multiply by the molar mass of water. If you're not already familiar, molar mass of water is just about 18. Hydrogen is 1, 2 hydrogens is 2, and oxygen is 16. So the molar mass of water is 18.02. Notice I'm going to divide here, but I multiply here. So I'm just doing 10 moles times 18.02 grams, and that'll give me grams of H2O. Very similar down here. 24 grams of hydrogen. Its molar mass, though, is 2.02, 2 hydrogens. That's going to give me 11.9 moles of hydrogen. Mole ratio here is easier. It's a 2-to-2. So 2 moles of water, the coefficient of what I want on the top, what I'm given below, is 11.9 moles of water. And again, same thing at the end, though, because I'm trying to get to grams of water. So I'm going to take 11.9 times 18.02. You can already kind of see which one is going to be limiting. Oxygen only makes 10 moles of water, while the hydrogen, if you had plenty of oxygen, would make 11.9. So we're going to do these steps, put these in your calculator. Make sure that you get the same answers as I do. So for the oxygen, I can make 180.2 grams of water. For the hydrogen, I can make 214. So which one is going to run out first? Well, that will be the limiting, and that will tell me how much I can actually promise my client. The one that runs out first and makes the lesser amount is the oxygen, and it can make 180.2 grams. So since the amount of oxygen I started with makes less water, it is my limiting reactant because it runs out first, and what I can promise to my client is that I can give him 180.2 grams of water. Okay. Now, I'm going to have some, since if I had unlimited oxygen, I could make more water. I'm going to have some hydrogen left over. So I'm going to need to figure out the excess, how much hydrogen is actually left. How would I do that? Okay. So in this case, oxygen's the limiting. To figure out the excess, you need to see how much hydrogen is needed to react with that amount of oxygen. So this time we're going to go 160 grams of oxygen, and we're going to see how much hydrogen would be used to satisfy that 160 grams of oxygen. So our wanted is going to be grams of hydrogen. How much hydrogen do I need? Again, we're going to convert to moles, mole ratio, convert to grams, and then we get what we want. All right, so 160 divided by 32, that'll give us moles of oxygen. We call that was 5 moles. We've got a 2-to-1, 2 moles of hydrogen every 1 mole of oxygen. So that's 10 moles of hydrogen. And remember, a mole of hydrogen is 2.02 grams, so we're going to multiply. And that's going to mean that we have 20.2 grams of hydrogen necessary to react with the 160 grams of oxygen. That's how much hydrogen was used. Now remember, we want to know how much is left over. So are we done with this problem? Okay, to figuring out the excess reactant. Well, we used 20.2 grams, but we had 24 grams. So how would you figure out how much was left over? You started with 24 and you used 20.2. You're right, you would subtract. So the leftover, you started with 20.4, what you used was 20.02, so you would have 3.8 grams of hydrogen left over. The excess reactant is the hydrogen, and you'd have that much H2 left over. So that is your video on limiting reactants. Remember to just keep practicing your stoichiometry, and the only difference about a limiting reactant problem is that you're going to have to do 2 stoichiometry problems to figure out which one gives you the lesser amount.